Okay, we're picking up on the Chapter 7 test version C with question 10 and part C, which says, what is the expected number of foreign-born residents in a randomly selected group of 3? The expected value was going to be each event times its probability, 0 times 0.389, plus 1 times 0.4316, plus 2 times 0.1597, plus 3 times 0.0197. You put that in your calculator, you're going to get 0.8101. The standard deviation, again, the formula, you're doing the x value minus the mean, so 0 minus 0.81 squared times the probability of it happening, 0.389, plus the next one, 1 minus 0.81 squared times the probability of it happening, 0.4316, etc. You're going to add all that up, square root, you're going to get 0.7691. Okay, looking at question 11 next. It says, a study of the weights of the brains of Swedish men found that the weight x was a random variable with mean 1400 grams and standard deviation 20 grams. Find the numbers a and b such that y equals a plus bx has a mean of 0 and a standard deviation of 1. So our formula for this, the mean a plus bx, the mean of y is going to equal a plus b times the mean of x. We know the mean of x is 1400. The mean of y is going to be 0. So I have 0 equals a plus 1400b. I can't directly solve that because I have two unknowns. So I'm going to go over to the standard deviation of y, which is going to be the square root of b squared times the variation of x. And I know that the standard deviation of y is going to be 1. And I know that the standard deviation of x was 20, so 20 squared is 400. 400b squared, and we take the square root, is going to be 1. There's only one unknown, the b. I'm going to square both sides. I get 1 equals 400b squared, divide by 400. Square root, you're going to get b is 1 over 20. Then you take that number, plug it in over to the mean equation. 1400 over 20 is 70. So a has to be negative 70. So my two values are a is negative 70 and b is 1 over 20. And question 12 says the length of human pregnancies from conception to birth varies according to a distribution that is approximately normal with a mean 266 days and standard deviation 16 days. Let x and y be the lengths of two randomly chosen pregnancies. What is the probability that x plus y is more than 600? So first I need to find the mean and standard deviation of x plus y. The mean of x plus y is just the mean of x plus the mean of y. Both of these events, because they're based off just two pregnancies of the same mean and standard deviation, we're just doing 266 times 2, which is 532. And the standard deviation of x plus y is the square root of standard deviation squared of x plus standard deviation squared of y. Both of these are 16, so 16 squared plus another 16 squared. We take the square root, you're going to get 22.627. And to find the probability that it's more than 600, and it's a normal distribution, we're using normal CDF on the calculator. Your lower bound is 600, your upper bound is some huge number. The mean is 532. The standard deviation is 22.627. You put that in the calculator, you're going to get 0.001327. I have all these decimal places because the key is I wanted 4 significant figures, and so I had to use 6 decimal places to get the 4 significant figures. All right, that's the whole test for Chapter 7, version C.